Okay, so today what we're going to be working on is the calibration of the determining the mass percent of copper that is found in brass. So overnight I took copper pellets and I diluted them, and then I just basically extracted the copper from the brass, since brass contains copper, and there's a certain amount of copper in the solution that we see here. So now what we're going to do is we're going to use this guy, which is called a calorimeter. So it's going to send a certain wavelength of light through it. And basically the thing that you need to keep in mind is when solutions are more dilute, there's a lot more room for that light to go through, and then we're able to determine how many particles are present or not in that solution. So basically the more dilute something is, you're going to see it not take as much time, and therefore light gets through a lot more easily than if something was more concentration or more concentrated. So in that aspect, you have to think about molarity. So molarity is moles over liters, and the bigger the number of molarity means the more concentrated or the more substance that a solution has. The smaller the molarity, the more dilute, which means that there's less of your substance for every liter of water or whatever liquid is being mixed. So the 5 solutions that we're going to start off with is 0.04, and I want you guys to kind of take note of the color as I hold it up to the video of the solution. So we got 0.4 molar of copper to nitrate, and then we have 0.2 molar of copper to nitrate. Then we have 1 molar of copper to nitrate, 0.1 molar, sorry. And then we have 0.05 molar of copper to nitrate. And last but not least, and I'll hold this up a little bit more, here we have 0.025 molar of copper to nitrate. So take note of how the color is changing from the first one that I included all the way to the last one that I just previously showed you. So right now we're running the calorimeter at 635 nanometers. So I've already calibrated the cuvette. So the cuvette that I am placing the solution in and then placing into the calorimeter. Sorry, was not prepared for this. Looks like so. So cuvette is what we put into anything that's going to have light emit through. So there are 2 sides that are important. The sides that you see here with the ridges, that's the side that you want to make sure to hold your fingers on, so that way it doesn't get too greasy, there's no scratches, because on the clear side, that's where the light is going to shine through. When we place this into the calorimeter, you don't want any scratches or smudges, because as we've learned in chemistry, light is easily manipulated based off of the surface that it comes in contact with. So with any scratch or with any smudge, it's either going to bounce back or not be able to get through as strong than if it was clear. So what we always make sure to do is we always make sure to rinse this with DI water in between solutions, and we always make sure that the clear side, you wipe it with what's called a chem wipe. So a chem wipe is basically, think of it as like tissue paper that you use for gift wrapping, but because it's chemistry, we give it a nice fancy name like a chem wipe, okay? But it basically has that kind of texture. So then we clean the outside so that way it allows light to go through. Okay, so that's my little demo cuvette. Another thing you always want to make sure is when you place the cuvette into the calorimeter or into the mass spectrometer, you want to make sure that you always line up the sides to the arrow. So the same side always needs to be lined up to the arrow. So sometimes your teacher or your professor, if you guys decide to take chemistry or any chemistry course in college, they will already have this side marked. Sometimes cuvettes have little arrows already built on them or engraved in them to help you with that. So my cuvettes don't, so that's why I put a little Sharpie marker right there to make sure that this is the side that I need to line up with the arrow that's inside of my calorimeter. So I've already calibrated with a blank cuvette. So I'm going to take out the cuvette that I was using before. Okay, so I'm going to, again, touch the sides with the ridges and not the clear side. And I'm going to clean the clear side as best as I can. Now I'm going to gently place the cuvette down, and then I'm going to start off with, according to our lab report. Right now, if you're following along with me in the procedure, I am on step 5 of the 3rd page, okay? So step 5 says to empty the water from the blank cuvette, which I've already done, and then using the most dilute of the copper 2 nitrate standard solutions, rinse the cuvette twice with 1 milliliter amounts, and then fill it with 3/4 of the way full. Okay, so I'm going to start off with my most dilute, which was the one that I showed you guys last. Okay, so I'm going to kind of rinse this and then dump it out. So that way at least the sides have the same amount. And then I'm going to fill this about 3/4 of the way full. Okay, so about this amount for those of us that would like to see. Okay. So I am now going to, so for the last time, just before I place into the calorimeter, I'm going to wipe the outsides of the calorimeter. Then again, touching the ridges, I'm going to place it into the calorimeter, make sure that my marker is lined up with the arrow. I'm going to now close it, and then manually add. Okay. And then I'm going to press, sorry guys. Okay, and then pressing the calorimeter button, the light is indicating right here that light is being emitted. So once it stops blinking, which now it does, that means that it has already finished shooting light through, and therefore it's ready to show.